Bismillahirrahmanirrahim. Assalamu alaikum. I am Asra Malik from University of Engineering and Technology Texla and member of Syndicate of Embedded and Electronic Design. Today I am here to present my research paper based on detection of insomnia using electrocardiography and electromyography. The contents are introduction, literature review, methods and materials, results, conclusion and prospects. So basically, what is insomnia? Insomnia is a sleep disorder in which you have trouble in sleeping or falling asleep. This condition can be chronic or acute. It is chronic when it happens at least 3 nights a week for 3 months or more. Common causes of insomnia include stress, traveling, poor sleeping habits, eating too much late in the evening. Insomnia symptoms may include waking up too early, daytime tiredness, sleepiness, irritability, depression, anxiety, and ongoing worries about sleep. So method we use for the detection of insomnia is ECG and EMG. So electrocardiography is a measure of electrical activity of the heart. It is a voltage versus time graph, which is obtained using electrodes placed on skin. These electrodes measure electrical changes which are the results of the cardiac muscle depolarization followed by repolarization during each cycle. ECG has three main components as shown: P wave, which represents the depolarization of atria, QRS complex, which represents the depolarization of ventricles, and T wave, which represents the repolarization of ventricles. Similarly, other method which we use is electromyography. Electromyography is a procedure that evaluates the health condition of muscles and nerve cells that control them. These nerve cells as motor neurons. They transmit electrical signals that cause muscles to contract and relax. So in past, different techniques are used by different researchers for detection. Like in 2015 and 16, EEG electroencephalography is used for detection, and in 2018 researchers use EDA, that is electrodermal activity with high pass filter is used for detection. In 2019, EEG with the extraction of different spectral features are used for its detection. Our proposed methodology consists of certain steps. These are data acquisition, feature extraction, preprocessing, and classification. So in the first step, we acquire data. We take all the data from PhysioNet. Our data consists of two classes, normal and insomnia. So 4 are males and 5 are female samples in case of normal, and 7 are male and 9 are female in case of insomnia. So we have total of 25 samples. So after data acquisition, our next step is preprocessing. For preprocessing, we use empirical mode decomposition technique. This is a technique which is used for denoising and extracting region of interest from signals. It decomposes a signal into oscillatory modes known as IMF. So in our case, we use only first IMF and rejected all other IMFs. So these are the ECG and EMG signals before and after preprocessing of normal and insomnia subjects. After preprocessing, next step is extraction of features. So in both ECG and EMG signals, we extracted different time and frequency domain features. Like for ECG signals, we extracted interquartile range, total harmonic distortion, spectral decrease, quantile 75%, mean, standard deviation, and skewness. For EMG signals, we use kurtosis, cross factor, impulse factor, margin factor, total jitter, log energy, total harmonic distortion, mean frequency, enhanced wavelength, slope sign, changes, Wilson amplitude. After extraction of feature, next step is classification. So apply two classifiers. These are KNN and logistic regression. After applying features and classifier, we obtain certain results. As shown in table that we get 100% accuracy on mean, interquartile range, total harmonic distortion, standard deviation, skewness, quantile 75%, and spectral decrease for ECG. And for EMG signals, we get 100% accuracy on kurtosis, cross factor, impulse factor, log energy, total jitter, margin factor, enhanced wavelength, slope sign changes, Wilson amplitude. Classification performance of proposed features over several classifiers. Maximal results obtained by using KNN for ECG and logistic regression for EMG, that is 100% result. This is the graphical representation of different classifiers. Classifier analysis is performed by 5-fold cross-validation. K-fold cross-validation techniques are an effective way to evaluate classification model results. Class-wise accuracy in the form of confusion matrices show that we get 100% in case of logistic regression and similarly 100% in case of fine KNN. So at the end, we concluded our research that our proposed model is based on rational signal analysis and classification of ECG and EMG signals obtained by minimal cost and non-invasive sensors. ECG and EMG signals with derived features and classifiers which give 100% accuracy is a completely novel approach. In future, we are aimed to detect more sleep disorders and comorbidity. We are aimed to reduce number of features as there are many features we used, and we also aim to use more signals for identification of insomnia and other sleep disorders.